Hello everyone. Today we are going to discuss numerical problem related to operators in quantum mechanics. So the question is, by what factors do the operator x square, px square plus px square x square and half inside the bracket we have x px plus pxx whole power to differ? We need to find by what amount these two operators differ. That is, we need to find the difference between these two operators. And we can see in this question, we have x component of momentum, and x component of momentum in operator form can be expressed as px equals minus I h bar d by dx. Okay. Now we have px square. So px square equals square of minus is plus and square of I is I square, h bar square del square by del x square. So we can write px square equals I square is minus 1. So we have minus h bar square del square by del x square. So we use this relation in this problem. Now let us define a function. So let g be a function. Okay. So we are taking g as a function. Now these two operator operates on function g. So let us take this first. Okay. So I'm writing taking x square px square plus px square x square, and let us associate function g. Okay. So we can write x square. Now we have minus h bar square del square by del x square. Okay. So we have this. So let me use curly bracket. Okay. Plus again we have minus h bar square del square by del x square, and we have x square. Okay. And outside the bracket we have g, function g. Now this function, okay, this is the function. So we can write in this way. Okay. X square, we can take minus h bar square as common. So minus h bar square is taken as common. Now we have x square. This x square is outside. Okay. Is outside or is towards left of the operator. So this operator operates on function g only. Clear? So we can write del square g by del x square plus next we have del square by del x square, and we have x square and g. Okay. Now this operator operates on x square and g. So we can write in this way. Okay. So we have second order derivative. We can write in this way. Okay. Now this operator will operate on x square as well as on g. So we use a chain rule. Okay. So let me write in rough. So we get this x square is free del g by del x plus next g is taken as constant. So we have del x square by del x, and this gives me twice x. So we get twice gx plus x square del g by del x. So we can write minus h bar square x square del square g by del x square plus del by del x, and we have twice gx plus x square del g by del x. Okay, now we have this. Okay, now again this operator will operate on g as well as on x. 2 is constant, so we can take 2 in this way. So operating on g, okay, we get this. Now operating on x, we get twice z, because we know dx by or del x by del x is 1. Okay, so we have this plus, now this will operate on this as well as will operate on this term. So we have x square del square g by del x square plus, next we have twice x del g by del x. Okay, now we can write in this way. So we can see, we can add these two terms. So we can write 2x square del square by del x square, and we have g, plus we can add these two terms and we can write 4x del g by del x, and we have twice z. Okay, twice z. Now we can write this relation in this way. Okay, so let me use this bracket now. Two x square del square by del x square plus 4x del by del x plus 2, and we have g function outside the bracket. So I'm writing over here. So x square px square plus px square x square, okay, on operating on function g, okay, gives us minus h bar square 2x square del square by del x square plus 4x del by del x plus 2, and we have g outside the bracket. Now we can simply remove g and write in this way. Okay, so let me erase this. Okay, and let me rewrite again. So this operator can be written in this way. Okay, minus h bar square 2x square del square by del square del x square plus 4x, okay, del by del x plus 2. So we can write this operator in this way also. Okay, so this is one result. Now we go for this. Okay, so let me erase this first. Now taking this, okay, x px plus So we have px x whole square, and let us associate this operator with function g. Okay, so we have this. Now we can write this relation. So we have half over here also. Okay, and this way x px plus px x, and again x px plus pxx, and we have function g. Okay, now at first this term or operator will operate on function g. Okay, so we need to understand this. So this operator or this term will operate on g, and then we get some result, and that result will be operated by this term or operator. So we need to understand this. Okay, so let me erase this. Now we know px is this, so we can write half x px plus pxx. So x minus, let me use this, okay, curly bracket, minus IH bar d by dx plus minus IH bar, okay, d by dx, and we have x, and outside we have g, that is function g. Okay, now we can write half this minus IH bar can be taken as common, so we can write minus IH bar is taken as common. So we have x px plus pxx. Now in this we have x, okay, d by dx, and this operator is associated with function g. Okay, so we have this plus del by del x, and we have xg. Okay, we have this. Now let us simplify this term. Okay, so del by del x, and we have function x and g, so we get this result. We can write minus IH bar by 2 x px plus pxx x del g by del x. So this gives me, okay, this term gives me x del g by del x plus, so this is 1 plus g. Sorry, so we have minus I h bar by 2. Now we have this, okay, x px plus pxx. So these two add up to give us twice x del g by del x plus g. Now this operator, okay, this term operates on this. So let us express px in this form. Okay, so we can write minus I h bar by 2. Now we have x, again we have minus I h bar del by del x. Okay, so let me use this bracket, plus minus I h bar del by del x, and we have x, and we have this term, okay, twice x del g by del x plus g. Now we can take this common, so we get minus minus plus, and we have I and I square, so I square is minus 1, so we get minus h bar square by 2, because we have h bar and h bar. Okay, so we have this x del by del x, okay, plus del by del x, and we have x, okay, towards right of this operator. So we can see in this case over here we have x towards left of this operator. Now we have 2x del g by del x plus g. Now this operator will operate on these two terms. Okay. Similarly, this operator will operate on these two terms, and we have x towards the right of this operator. Okay. So this will operate on this also. So we are going to see it later. Okay. So let me simplify and write, okay, x. So let me use this bracket. Okay. So it is operating on this, and again it will operate on this term. Okay. So x del g by del x plus this will operate on this. Okay. So we have del by del x, and we have x and this twice x. So this gives us twice x square del g by del x, and again this will operate on this. So plus del by del x, and we have x and g. Okay. So xg. So we have this. Clear? So let me write over here. Okay. So I'm erasing this. So we can write this as minus h bar square by 2. So we have x. Now this will operate on x as well as on del g by del x. So we get twice x del square g by del x square plus 2. This will operate on x. So 2, and we have x over here. Okay. Del z by del x. Clear? So we are getting this. So I can rewrite this as twice x square plus we have x del g by del x plus 2. Now this will operate on this x square and will give twice x del g by del x. So we can simply write 4x. Okay. Next, this will operate on del g by del x. So plus twice x square del square g by del x square. Now we have this. Okay. Plus x del g by del x plus g del x by del x. So we can write minus h bar square by 2. Now we can see, we can add these two terms and write 4x square del square g by del x square, and we can add this. Okay, here is positive sign, this and this term. So 4, 5, 6, 7, 8. So we have plus 8x del g by del x. Now the remaining term, so this is 1. Okay, del x by del x is 1. Now the remaining term is plus g, and we can write this in this way, okay, minus h bar square by 2 4x square del square by del x square plus 8x del by del x plus 1, and we have g outside the bracket, okay. So now we can say in this relation, okay, for this operator we have minus h bar square. This is minus, okay, minus h bar square. So let us write in that form, okay. So minus h bar square. So I'm using this bracket now. Let us take this 2 inside the bracket. So we have 2x square del square by del x square plus, now we have 4, okay. This will cancel it, okay. So 4x del by del x plus half, and we have g outside the bracket. So finally we can write this operator, okay, that is half x px plus pxx whole power 2 as minus h bar square bracket 2x square del square by del x square plus 4x del by del x plus half. So this is the another result, okay. Now we are asked to find, let me erase this first, okay. We are asked to find the difference, okay. So let me erase this also. And we have found this operator, okay. Let me write in this way: x square px square plus px square x square can be written as minus h bar square 2x square del square by del x square plus 4x del by del x plus 2. So we have this. Now we need to find the difference, okay. We are asked to find the difference. So the difference we have to subtract. So let me call this as 1 and this is 2, okay. So we can subtract 2 from 1. Clear? So difference is this. So let me write in this way, okay. Minus h bar square. Let me write in this way, okay. Minus 2. I'm opening the bracket, okay. H bar square x square del square by del x square minus 4h bar square 4h bar square x del by del x minus 2 h bar square, okay. And we have this minus 2 h bar square x square del square by del x square minus 4 h bar square x del by del x minus half h bar square. We have to find the difference, okay. So we need to find the difference. So let us subtract it. So these two terms cancel, these two also cancels. So we have minus 2h bar square plus 1 by 2 h bar square, okay. We have this. So we can simplify it: minus 2 plus half h bar square. So minus 4 plus 1 by 2 h bar square. So we get minus 3 by 2 h bar square. So finally, we have found that these two operators differ by the amount or differ by the factor minus 3/2 h bar square.